So these are also called exceptional conditions. Generally, the processor first condition is reset. So first condition of interrupt is reset condition. So this programmable device, like this, whatever microcontroller you are working on, you'll find there will be a reset pin. So this reset pin, when it is activated, either high active or low active, let's say high active, then it has to be activated for certain clock cycles. Then what happens? The microcontroller executes with respect to the program counter, which points to the program memory. So with the help of reset, it gets into a particular address. It could be 0000 or FF whatever. So this is the first unusual condition when you reset it. So the program counter after resetting will become all 0. 14 bits will be all 0. So as a result, what will happen? So this will point to the first memory location, let's say, and it will start executing the code, whatever is written in the program memory, starting from the 00 location. So you can write your boot program there. So this is one unusual condition of reset. Then there are interrupts. So the interrupts are required whenever the code, the microcontroller is executing a given code. So it goes serially one after the other. If there is a jump instruction, call instruction, whatever, so it goes on looping. So one point of time, if there is some exception, for example, it is connected to an external interrupt, external device, where there is some fault or something. In that case, this processor, this code should not run. So it should address the requirement of the external. So this interrupt, what it does, it enables, when the interrupts enable, so the program branches to something called an interrupt service subroutine, ISS, which is called interrupt service subroutine. So these are all these conditions. Similarly, when the timer is running, serial port is running, then I2C is running. So all of them, when they receive and send data, like AD converter running, so everything has an interrupt. That means when the AD conversion is completed to interrupt, so you can have interrupt-driven data transfer. So for that matter, so we call it exception handling, and every processor has this. Okay, so I'll share one of my presentations, which will make you easier to understand. So if you look at this figure, you can take a note of it or whatever. I'll share this notebook I am. So if you look at this figure, so this figure shows you the different things. Like, you know, you have got the processor, CPU, which program counter and instruction register. This is your instruction register, IR. This is your PC, program counter. Interrupt request comes from the external device. This is the external device. So this external device may be connected. For example, you are measuring current or temperature of a room. If the temperature goes higher than certain value, you should switch off the heater. So there is a temperature sensor, TS, temperature sensor, and there is a heater element, heater. So this heater is connected to a relay, through a relay. This is a relay mechanism. So it has closed it. This is a relay. So this temperature sensor is feeding to a microcontroller, and the microcontroller is capable of switch off this relay. So whenever this temperature sensor data goes above a threshold, there should be a device here which will measure it, and even if it is above the threshold, it will interrupt. Once you are interrupting the processor is doing some usual stuff. Then it will do an acknowledgement, interrupt acknowledgement. Then the address of the interrupt service subroutine is required. So by means of which it will jump to the interrupt service subroutine, and it will address the external device and switch it off. So this is the job of the interrupt in a process control environment. So if you see, let me share this, present this. Okay, that will be better. Let me present this one to you guys. Can you see my screen? आप लोग स्क्रीन देख पा रहे हो? तो
यस सर, यस सर।
रोहित यादव, स्क्रीन दिख रहा है? रोहित यादव, रोहित यादव थोड़ा बुलाओ, लेट हिम कम, आई वांट टू टॉक टू हिम. रोहित यादव, yes, Pooja, are you there? This Rohit Yadav,
yes, sir.
Even a red, very nice red. I am also noting down his name.
Okay, sir.
Actually, this is becoming too much for me. If there are 3 students who will not respond, then I will not take any more classes. Let them read and pass. Rohit Yadav, I have marked him. Rohit Yadav कहाँ है? तुम्हारा दोस्त कोई है, उसको बुलाओ. I want to talk to him. This guy is. I have also marked his name. Srija Reddy? Srija Reddy?
Yes, sir.
Can you see my screen?
Not now, sir. Before I saw it, sir, but not now.
This one, right? You can see this, okay? So, if you see, look at this. Is it visible to you? So this is the main program. Main program is the processor goes and executes certain predetermined program code.
Hello,
So
sir.
whenever there is interrupt, so it jumps.
It is not visible, sir.
Pardon?
The screen is not visible, sir.
Okay, I'm sorry about it. So this is visible now, right? Now the screen is visible.
Yes, sir.
So if you look at this, this program flow, this is a main program, and you can interrupt the processor through some hardware, stuffs like interrupts. If you look at the Atmega 32 pin configuration, that 328 pin configuration. So I can show you that pin configuration right away. So there are many interrupts if you look at them. So let me just show you that pin configuration. I'll come back to the pin configuration later, don't worry. I'll just let me finish this. So if you look at this ISR means interrupt service subroutine. It is different from ordinary subroutines. Because this is interrupt, this has to go to a particular address. The address can be obtained automatically by hardware, or you can read the address from a vector table. So to get the address, there is a interrupt vector table. You can write down interrupt vector table. Interrupt vector table. Okay. So we'll come back to that. And the interrupts can occur anytime. That's why it is not synchronous with the clock. It is called asynchronously it will occur. It is not synchronous with any clock. So therefore, but interrupt acceptance will be synchronized with the clock. If the interrupt occurs at the middle of the clock cycle, but at the end of the clock cycle, the interrupt will be accepted. So if you look at the, let me just show you the execution of code, that will be better. Otherwise, you will have difficulty in understanding this. Let me tell you the execution of code. You can have a better idea. So if you look at the AVR Atmega code executions, how with the clock it is synchronized. If you have read it, fine. Otherwise, you can see it here. First of all, look at the pin configuration of the Atmega. That will be first. You will know where are the interrupt signals. That is the first AVR 32. This is your AVR 32. If you look at them, so you can see my screen, right? So if you look at these signals of Atmega 32, 326, these signals you can see. Can you see these signals? Hello, can you see the signals?
Yes, sir.
Okay, so you can look at this. There is lot of interrupts. Like this is called pin change interrupt, PC int. Pin change interrupt is, that means most of the pins can be enabled as pin change interrupts. That means if there is a change in the level, interrupt log. If you enable pin change interrupt, that is PC interrupt, or pin change interrupt. Pin change interrupt. This is a special feature in this particular device. That means if any of these, but if you put it in this mode, that means if you enable this by way of some enabling flags, the pin change flags, what would happen? This all these PC ins, every pin of the ports, basically port B, port A, port C. This is port D, port C, port D. You can see port B also. So they will be configured at interrupts. That means any level change in that will make an interrupt. Similarly, external interrupts are also there. If you look at INT0 and this is INT0, you can see here INT0, and there is one more INT1. So these are the external interrupts. INT0 and INT1. This is INT1. So these are external interrupts. When you enable external interrupts, so they will be, these two pins will be treated as interrupt pins. But internally, because this Atmega has lots of devices on the board. For example, if you look at the architecture, this has this Atmega 326 has got several devices. So this is the architecture which you guys by this time must have understood. So if you look at this architecture, so there are many other devices which are on the chip. For example, there is a timer, there is a watchdog timer. We'll talk about there is a EEPROM, so there is a USART, there is a serial communication, two-way interface. TW stands for two-way interface, serial port interface, then ADC, analog comparator, and there are timers, TC, timer counter, TC for timer counter. There is 1 to 8-bit, 1 16-bit, 1 8-bit, so 2 8-bit, 1 16-bit timer. So these are all actually they connect to the external device. AD converter connects to the analog signal. 16-bit counter sends signal outside. Then this USART is connected to serial port. So when the receiver send data, they need also interrupt. So each of them has an internal interrupt to the CPU. So these are also having interrupts. So anyhow, so let me discuss how the interrupt will be taken. So let me tell you about the execution of the instructions. So that will make it easier for you to understand. So generally this Atmega 32, there is pipeline processing of instructions. While one instruction is being executed, the other instruction is gotten from the memory. I have taken it from your manual, you can see. So this is how the parallelization is happening. You can see first instruction is, first it is, when the first instruction is, second instruction is fetched, the first instruction gets executed. Similarly, this is pipeline. Instruction 1, instruction 2, instruction 4, they are fetched in pipeline fashion, one after the other. While one instruction is getting to the CPU, the other instruction may be executed there. So these three are independent cycles. And this is interacting with the memory when there is instruction fetch. And this is not interacting with the memory when the instruction execute. So there is a staggering of the stages. So this is called pipeline execution stage. So I have told you about the micro steps. So if you look at some particular single cycle instructions, so if you look at this, how the single cycle instruction takes place, you can see this, like add, AB, etc. So this is how a single cycle instruction execution takes place. So in the first clock edge, as you can see here, this is the first clock edge. The addressing mechanism, program counter addresses the flash memory or the code memory. So the address goes and the instruction is found out, goes to the instruction register where the decoding will take place. So this happens in the first rising edge. Then the execution occurs in the next rising edge. Then write back, etc. occurs in the third rising edge. Write back to the registers, etc. If it is a memory write, then one more cycle. So this is one complete cycle of the instruction execution. So these are all synchronous. But interrupt can occur here, here, anywhere. So what does it do? If there is an interrupt occurring here, it will complete this cycle. Then it will process the interrupt, provided the interrupt is enabled. So that is how interrupt, even though it is asynchronous, it is accepted by the, it will set a flag. Whenever there is an interrupt, it will set a flag. And the flag will be read or sampled at the end of the one instruction cycle. Then it will go to the next. So while this instruction is getting executed, at the same time, the other next instruction may be fetched from the memory. So there is a, so that means here at this point, there may be instruction, other instruction coming in. So therefore it becomes faster. So this is called pipelining of the instruction page. Is it clear to all of you? Is it clear? Any doubt here? Please ask me. So let me come back to the presentation. So as you can see here, suppose a peripheral is interrupting the processor, as I said earlier, like this. The peripheral is interrupting. There is an interrupt request coming from the peripheral to the PC. Then there is, so the external interrupt is accepted through this INT pin. So there are two ways. The processor will wait and see who has interrupted. That is number one. Or the processor will automatically accept this interrupt and go to a subroutine. So what did you do in ADC? You did polling. That means after you start the conversion, there is a end of conversion. So this end of conversion is continuously monitored by the processor. There is a wastage of time. Instead, you can use end of conversion to AD conversion to interrupt the processor. So let's see how it happens. So there are two to three different types of interrupts. So one is called fixed interrupt, one is called vector interrupt. Sometimes the vector interrupts are implemented through interrupt address table. What is fixed interrupt? The moment you interrupt, it goes to a fixed address. That is called fixed interrupt. If it is a vector interrupt, the moment you interrupt, it will look for an address. So this address can come from the external device, or it can read an interrupt table, vector table, which is more practiced now in this Atmega 328. There is an interrupt vector table. So it will read that address and go to that address for ISS, or interrupt service subroutine, ISS. So these are the three: fixed interrupt, vector interrupt, or vector interrupt through a table. So if you look at this particular figure, you can have a very good understanding. Look at, there are a main program, instructions are there at 100 and 101, as you can see here. And there is a interrupt service subroutine as ISR, which is written for memory 16 to 19. So there is one particular thing it has to do. The ISR is supposed to, there are two peripherals which are connected to the microcontroller, that is P1 and P2. So it is supposed to just modify or take one value from here and put it here. Let's say that is the job of the interrupt. Whenever this peripheral has a data, it will interrupt. And the interrupt service subroutine is supposed to take this data from here to here. Let's say that is the case. In that case, so my microcontroller is in the main program. It is the program counter is having 100 or 101. So then there is an interrupt. So what happens? Let's see. So if you look at the subsequent figures, you see there is an interrupt. So the data is received. So P1 will make it 1. INT becomes 1. If you look at it, this INT becomes 1. The moment INT becomes 1, the program counter is pointing to the main program. Let's see what happens. It will go to a fixed address. That means automatically it is hardwired to go to 16. If INT becomes 1, internally it is hardwired that it will go to 16. So you see it goes to 16, and this 100 goes where? Where does 100 go? Where does the 100 go? Domala Nihar. Wait, Domala Nihar. Are you there? Domala Nihar. Domala Nihar, are you there? This is pretty bad.
Yes, sir.
Why are you joining in this? You are not responding properly. Why are you in this? Is it a child's play? I am teaching you. I am a joker here. Huh? You please leave. You don't have to attend today's class. Please leave. Don't attend. Please leave yourself, otherwise I will remove you. Please leave. Please leave. अरे record है ना, तुम देख लेना बाद में. Leave. Okay, thank you. Okay. So where does this Srinivas Kalyan? Where does this 100 go? Srinivas Kalyan. Srinivas Kalyan, are you there? Srinivas Kalyan. Srinivas Kalyan, are you there? Srinivas Kalyan, can you come? Harsh Singh, can you tell me, Harsh Singh? Where does that PC program counter content go?
So in the stack.
Very good. It goes to the stack. Thank you very much. So this program counter content goes to the stack. You're right. So when the ISR is executed, just like call instruction, it goes to that. Let's see what happens next. So next is this execution happens. In the execution, what happens? This goes to R0 register. Then R0 gets modified. Then it goes to the 8001. So all these execution takes place. Then again it returns back to the program counter. You can see it goes back and comes back. So you can see it again comes back to the. So this has been transferred. So now this has been returned and this IPC program counter has come to 101, next location. So this is the vector interrupt. That means whenever there is an interrupt, it is hardwired internally that it will go to 16. Okay, it is hardware. But that's not a good idea, you know, if you want to have some other place where there is a one more ISR, so what to do? So that leads to what is known as vectored interrupts. Vectored interrupts, you can write vector. So if you look at this particular thing, you know, you see this, how this vectored interrupt happens. So in the vector interrupt, it is called interrupt acknowledge cycle. If you look at this vector interrupt, this is called interrupt acknowledge cycle. Let me do something, you know, I can write there so that it will be easier for you. So I can put it to desktop 2 so that I can write. No, I'm not going to do that. Let's say I'll not write now. So this is known as interrupt acknowledge. That means whenever there's an interrupt, it has to acknowledge. After that, the address of the subroutine should also come. That means it occurs in 2 steps. First step, it will do interrupt. Then second step, it will get the address. So this address of the subroutine has to come from the external device. Okay. So in the first interrupt, the address is hardware. But in this case, this 16, the number, it has to come from the external hardware. That means this external hardware, or there is an interface chip which will be responsible for sending the address. So let's see what happens here. So there is an interrupt. After the interrupt, there is an interrupt acknowledge. After interrupt acknowledge, the 16 value will come from the peripheral. This 16 will go to the program counter, as you can see. So then there will be program counter will go to the ISR. So this is a little bit more step, but more flexible. So this is called vectored interrupts. Is that clear? Is that clear?
Sir, can you repeat once vector interrupt?
See, in the first interrupt, what happens? Whenever there is an interrupt, this interrupt, you know, it will automatically go to 16. It is hardwired inside. That means program counter will be flushed out or pushed into the stack, and it will this whole program counter will go to 16. This is fixed. If there are 3 interrupts, 3 addresses are fixed. If you do interrupt 1, it will go to 1 address, interrupt 2, another address, interrupt 3, another address. These 3 addresses are fixed. So my question is, but this is not good because you don't have flexibility of putting ISR anywhere. You have to put the ISR there itself. So the interrupt service subroutine should have a flexibility to be put at any address. So that leads to what is known as vector interrupt. In the vector interrupt, what happens? So the peripheral or the device which is accepting the interrupt and sending it to the microcontroller should send an address where the subroutine is. So this should be pre-programmed. For example, here, whenever there is an interrupt, so this will seek, the microprocessor or microcontroller will seek if there is an address which is coming, because this is vectored interrupt. So it will enable this interrupt acknowledge, by means of which this will transfer a address which is 16 here to the program counter. You can look at it. This address 16 comes and it goes to the program counter. So then the execution takes place and then the interrupt acknowledge is over. So this is typical of the, but you know, peripheral device cannot handle this address. It is very difficult. Therefore, we have got some interrupt interfaces. There are chips which can be used to do this for the peripheral or vector interrupt. So the third type interrupt is something little different. That means there will be a fixed interrupt which will go to an interrupt address table. So this fixed interrupt, you know, here, this one, you just see, this will lead to an interrupt. Instead of a ISR, it will go to an interrupt address table where the addresses will be written. So you can change the address here. So this will go to one address table from which it will read the address and it will load to the program counter. So this is also as good as vector interrupt, because you can really change the address here. So this interrupt goes to a particular address where the address is written. The address of the subroutine or ISR will be coming back to the program table. So this is called the third type of interrupt. It's called interrupt at vector table. So we just learned three types of vectors, three types of interrupts. One is the fixed interrupt type, one is the vector interrupt, one is interrupt address table. Now there are maskable and non-maskable. Some interrupts you cannot really disable, like reset, etc., power on things, gray out detector, etc. Gray out means when the power is switched off, generally you have supercapacitors on the chip, on the board. If you look at your board which you have purchased, there will be supercapacitors. Whenever there is a power off, the supercapacitor is slowly discharged. When this is discharging from 5 volt to down, this interrupt will be enabled. That is called gray out detection, and it will save the contents whichever is not there, which it will save the content, and there will be no garbage, because whenever there is a power out, the garbage is possible, because there will be, when it is power is coming down, voltage is coming down, 4.5 volt, 4 volt, etc. The TTL logic or whatever logic you are put, it might confuse it with 1 or 0. So there may be garbage written. So this gray out detector is responsible for taking care of this garbage. So therefore it is non-maskable. Then there are lot of stuff. So finally, I will not discuss this. This is an old AVR structure. I shall discuss something else, the new one. So this one I will just skip. I will not discuss this. So just remember this new AVR which you are using, it has got PC int, that is pin change detections. Lots of more interrupts are there. All right. So now let me have some interaction with you guys. So can have you understood this concept of interrupt? Okay, let me ask some questions to you guys. Be attentive. Abhijit Nandan, are you there, Abhijit?
Yes, sir.
Can you explain vector interrupts?
Yes, sir. Sir, so basically in vector interrupt, we have an address table, and whenever interrupt occurs, the program counter at first it puts the next address in the stack, and then it goes to
vector interrupt. That is a third type of interrupt, which is a compromise between fixed and vector. Vector interrupt means the external device is responsible for sending the address.
yeah. So it provides address as well as the
Now,
interrupt.
what is that cycle? What is the signal which goes back to the external device? External device interrupts INT. Then what goes back to the external device?
It provides, sir, I think only interrupt it provides, and along with that it provides address.
No problem. You should be attentive, otherwise you will miss the whole game. Interrupt is very important. If you miss it forever. You have to read number of hours to understand interrupt. So you have missed it. Okay. Bharat Krishna, you can tell.
Hello, sir.
Bharat Krishna, can you explain vector interrupt?
Yes, so 1 hour interrupt occurs. The address given by the it goes to the address given by the
signal
external
is what?
device.
One is interrupt signal goes to the processor. What processor gives back? Be attentive, that's the point. The whole point is you have to be attentive, otherwise I cannot help you. Okay, so let me ask to Kari Yadu Bansi Krishna.
Yes, sir.
So what goes back to the processor? All of you can figure out from the recording what goes back to the external. Whenever there is in case of vector interrupt, whenever there is an interrupt, what goes back to the external device? ये ऑनलाइन पढ़ाई में ठीक नहीं होगा, कुछ नहीं हो रहा है. कुछ तो क्वेश्चन पूछने तो तुम लोग कुछ समझे नहीं तो नहीं. Nausin, who can answer? Please raise your hand. Please raise your hand, those who can answer. Okay, thank you. Only one guy, two guys, Shubham, Ajay, that's all. Shubham Kumar, please tell.
Sir, interrupt acknowledge.
Good. So interrupt acknowledge. So when the interrupt acknowledge is accepted, it sends the address. Okay, Ajay, can you tell me what is the advantage of fixed interrupt? over vector interrupt?
Sir, there's no need of interrupt acknowledge, and it is quite
So what is the advantage of fixed interrupt? Advantage क्या है? ठीक है, वो सही है.
low latency.
Huh?
Low latency and
Yes, low latency. Excellent.
Sir, I have a question.
I'll take your question. Ajay Mishra, Pooja, you give a star. Okay, tell me. Yes, question.
Sir, if globally interrupt is disabled, then up to what step the interrupt, which is vector based, would be done? I mean, if status from
So there are many ways to disable. If you disable the interrupt and there is an interrupt, so what will happen? There may be a prioritize. Suppose there are 8 interrupts together. I have just shown you one interrupt. In the next, I'll show you different interrupts. So there is a priority setting. You can set the priority. Whenever the interrupt is enabled, according to the priority, it may be processed. That is number one. So sometimes, if there are some interrupts. If you disable it, it will not accept the interrupt. But there are some interrupts. If you disable it, it will accept, but the flag will be there. After whenever the interrupt is enabled, it will take the case. What is your question? Did I answer your question?
Yes, sir.
Okay. Rushali. Hi, Rushali. Rushali, are you there? Rushali Chakraborty. I can see you here. Rushali is not there. Rushali, please leave if you are not there. I will make it. Usko nikalo. She is not there actually. Okay. Rishita, are you there? Rishita?
Yes, sir.
Okay. So, what do you understand by this interrupt vector table? Can you answer this?
Actually, it will, whenever interrupt comes, it will go through the interrupt vector table and go to that address.
Will there be any interrupt acknowledged?
No, because there is already a table, it will go through that, and according to that, it will go to that address.
Thank you. Okay, so I think you guys have got it, but suppose you have missed it, please go through this video lecture or whatever you have recorded, and generally that never happens, right? So now I shall talk about something different. So let's talk about the AVR interrupts. Okay, what are the AVR interrupts? So let me just go to this. Okay. You can see my screen. So let's the Atmega 328 interrupts. It is already there in the manual, but still I should tell you something extra because that is very important. So this is done through interrupt vector table. Remember this. So in Atmega, this is interrupt vector table. So there are two things here, reset and interrupt. There are two things. Reset is like interrupt, which will reset the processor and restart the whole thing. So let me tell you a few things because things are little complicated here. There is a boot loading. There are some boot set reset. All these things will come, but we'll slowly go into this. We'll learn this processor completely. Don't worry about it. So I'll just show you the interrupt vector table. So this will make things easier for you. This is table 1.1 in page number 49. You can see that. So let me just put it here. Is this visible to you? I'll just increase the font size a little bit. Can you see? Can you see this vector table?
Yes, sir.
Nausin, can you see Nausin? Nausin.
Yes, sir.
Yeah, good. Okay, so this vector table tells what? This tells about the program address. Where is the address where the interrupt will go? So in that address, it will you can do the. So for example, there is a reset. Reset will go to all zeros. So how many bits is this address? कितना बिट का है? शुभम कुमार. Address कितना बिट का है?
The 2 byte. 2
No.
byte.
You are not trying. How many bits this address is? Who can answer?
16 bits.
64 bits.
No. Who can answer this? Please raise your hand.
64 bits.
No. This address, I'm talking about address. How many bits? Ronit Datta is not you are a TA, you are not supposed to answer. You are a teacher. Or you are a student. I have one Ronit Datta who is my scholar. Are you the scholar or the student?
Sir, I am the scholar.
So don't answer.
Yes, sir.
Who can answer? Please raise your hand. This address is how many bits? अरे address तो लिखा है इधर. At least तो 16 bit लिखा है. हेक्साडेसिमल नंबर है. कितना bit का है? 16 bit तो जरूर नहीं है. Who can answer this? In the program memory, what is the address size? Address. Who can answer, please? Somebody should answer. Please raise your hand. Ajay Mishra.
Sir, are you asking the memory size of flash in at Mega32?
No, address number of bits. That's what I'm asking.
Sir, it is 32K address, 32K size of memory of in 8
That is
Mega32.
true, but the program counter has how many bits?
As I can see, there are 16 bits, but I don't know exactly.
No, this 14 bit. I told you should be having very attentive in the last class. You read it. Otherwise, you guys are going to commit a lot of mistakes. Okay, because I have not given you the coding this time. This week I'll give you the coding examples. Okay, so this is a 14-bit address. If you see, the 32 kilobytes means 16 kilowatts. So this is a 16-bit number which is stored there. Are you getting my point?
Yes, sir.
Okay, can you tell me that the first address is 000, but the next address is 002? Why it is so? Anybody who can answer, I'll be very happy. Our next address is 004, 0004. Anybody who can answer, I'll give a star. Why not next 003? Why it is 004? तुम लोग कोई serious नहीं है और क्या?
Sir, is it reserved for clocking purpose?
No, I don't think so. अरे जो भी मन में आता है थोड़ा सोच के बता. देखो.
Like it is pointing 2 bytes at once.
Yes,
like
exactly. Who
bytes
told this? Who is telling? Please raise your hand. Shubham.
Yes, sir.
Shubham Kumar को थोड़ा स्टार लगाओ. So it is basically 2 bytes. So whenever this 14 bit is addressed, it is addressing 2 bytes. The 0th and so therefore reset goes to 2 bytes of address. Because 2 bytes नहीं होने से कैसे होगा? 14 bit है ना? So consecutive 2 locations has to be reserved for the address. Okay. Similarly, int 0, int 1. So these will have 2 bytes. It's an address in the vector table. So this is, you can see this, if you look at this. So this is external request interrupt. This is external request. So this will go to this. So that means you can connect your devices here. If you have any other external devices which you want to connect. Then these are pin change interrupts. Pin change interrupts 1, 0, 1, 2. There are 3 pin change interrupts. So I have shown you that. You can see here. If you look at here you can say there are lots of pin change interrupts, but they are accepted as 3. Group 1, group 2, group 3. Okay, so this will come here. PC 0, PC 0. PC into 1, PC into 2. It will come to these locations. Then the timer counter, because each timer will have a comparator. Timer is what? Basically, there is a 8-bit which gets in. We change these 8 bits whenever it goes to the highest number FF. There is a overflow, so there will be overflow, and it will compare, or this counter will compare with the external count, and if there is a match or mismatch, then so there will be a comparator match interrupt. Then comparator. There are two comparators, A and B, and also the counter overflow. And there is a counter capture event in timer 1. We'll talk about timers. Don't worry about timers. So timer 1 will have timer capture event. So using timers, you can really do many things. For example, you can do AD conversion independently. The timer will supply the clock and interrupt will take out the data. So it will automatically very fast and with equal intervals of time. Polling is not required. In polling, what will happen? If you write any code, the polling will be destroyed. You got it. So these timers 0. So this is for all reserved for timers. Then there is a serial port. We'll talk about serial port interface SPI. So this also does parallel to serial conversion, sends the data and receives the data. So it has to, an interrupt for then USART, then ADC conversion complete, then EEPROM ready, analog comparators, the 2-wire serial interface, store program memory ready. So this is how when you do flashing, that means when you are loading code into the AVR controller, this is flashing. So this is required. So all these interrupts, so there are 26 interrupts as you can see here. They are, whenever it occurs, it goes to a memory location where the address is stored, interrupt address. Are you getting it? Is it clear to you? Yaduvanshi Krishna.
Yes,
Yaduvanshi Krishna.
Yes, sir.
Clear. So why the address is 006 and 008? PC into 0, PC into 1, not 007.
Like each octet has 2 bytes of address. So
2 byte or 14 bits basically, because the code is program counter is 14 bits. So 14 bits means 2 byte has to be resolved. Okay. Is it clear to you? Okay. So let's go
could
to
you explain once more the timer part? Like, I didn't understand that.
timer. I have not taught. When I'll come to you, just remember that timers. There are 3 programmable timers: timer 0, timer 1, and timer 2. Each timer counter का काम क्या है? I will get back to after interrupt. We'll talk about it. This is responsible for generating timing pulses. Programmable means you can adjust the pulse width, you can adjust the frequency, everything. It is also used for event capturing. That means if there is an input which is going high, it will start counting. It is also used for counting, just counting. Number, suppose you have a optical encoder which is encoding the speed, so the pulses will come, it will try to count. So all these things are done by counter. You can program it, you can change the counting speed, you can change the width of the pulse, frequency, everything. We'll talk about different timing modes. So these 3 timers does that. So these 3 timers are programmable, but they also need processor attention, because processor has to code it, program it, right? Processor has to program it and processor has to set it, reset it. So therefore, they need also interrupts. Are you getting my point? टाइमर अभी नहीं पढ़ाया, टाइमर पढ़ाने के बाद समझ में आएगा, ठीक है? So don't worry about timers now. We are talking about interrupts only. Is it clear to all of you? So there are a lot of things, where to start the reset and where to start the interrupt vectors. So you can start from 002. You can also start from other locations by setting. There is a boot reset bit. We'll talk about how to flash the AVR and how to change the boot sector, etc. When you talk about that, we'll know. So from the boot set reset bit, you can start from a different location also. But generally, you start from these locations in the program memory. Okay. All right, so I shall discuss one interesting thing. Suppose, can you have a chip which is known as programmable interrupt controller, which will handle the program automatically for any processor? So we talk about what is known as programmable interrupt controller. Or PIC, we call it PIC. Okay. So suppose I have a processor, hypothetical processor, let's say, which has one interrupt, just one interrupt. But it has some interrupt acknowledge capability. This is just one interrupt. But actually I need to process something like 8 interrupts because I have 8 external devices. So what I need is an external chip which will take these 8 interrupts . Then finally bring out one interrupt here. There will be some priority. For example, each of them are interrupting at the same time. There has to be a priority scheduling. Also, whether you want to interrupt in the rising edge or on the level, so level triggering. So there has to be, it's a programmable interrupt controller. This is called programmable interrupt controller. So one such controller exists by Intel. This is called 8259. So the integrated version is available in your desktops and laptops, where there is a super IO chip which does all these programmable interrupt controller and timer, everything. So there the architecture is like 8259. So we'll discuss about a programmable interrupt controller before moving further into AVR interrupts mode. So each of the AVR interrupts will be taught when we talk about reset, pin change interrupt. Each one of will be taught. So don't worry about it. So let's discuss about little bit of programmable interrupt controller. So I'll tell you the chip and I'll discuss the chip with you so that you can have a better idea. So this is called programmable interrupt controller. So this is a typical architecture, something like this. So how it is placed, you can see this programmable interrupt controller. This is your microcontroller. It has got a bus architecture. This is called a processor bus or the system bus. We call it system bus. What is system bus? What is bus? What is port? So bus is, the signals are faster here. You can have address, you can have data, you can have control. So address, data, and control. So together, all the pins, when they are available just like that. So this is called address bus, this is called data bus, this is called control bus. So you can connect any devices onto it who are matching the speed of the processor. For example, here you see there is address bus, data bus, and control bus. Control bus matlab kya? Control bus means what? What are the signals for the control bus? Address bus is addressing, data is data. What is control? Kitiz Kumavat? Kitiz. Hello, Kitiz, are you there?
Yes, sir, I am here.
What do you mean by control bus? Look at this.
Something like a controlling.
What control? Tell me one thing. You tell.
Sir,
Address bus is unidirectional. Processor is the master here. Data bus is bidirectional. Control bus can be both the directions. So tell me control bus का एक signal बोलो. Like read. For example, memory read, memory write. These are signals which has come to. If you want to write to the memory, you send an address, then do memory write, then data. So the memory will be written. Okay. Similarly, this interrupt, acknowledge, they are control signals only. Reset is a control signal which changes the state of the processor. Okay. So these are control signals. Anyhow, so these are all connected. So this is called a bus, system bus. We call it system bus. So what is a port? Suppose I say it's a system port. What do you understand? Hemasri? Hemasri?
Yes, sir.
What do you understand by a port? Suppose this is a bus, there is a port. मैं क्या first class में बोला? You say data bus, address bus. Sometimes you call data port.
So is it based on like the components present?
Yes, components means there are the port holds your data for some more time.
Okay.
So when you data transfer, so there is when you transfer data between different devices. Suppose there is one device here. Let's say this is your microcontroller, and there is a peripheral device here. Let's say whatever peripheral device, some device. So when you want to transfer data from one to here, how do you do? First you send the address, then you can send the data. You can make a write operation. So in this case, the device should be very ready and very fast. The moment you send address, microcontroller is going to send with clock, right? Like this. It may send address here. This is the address which is coming. Address bus. Then the data will be sent next. This will be your data. Next is data. So that means what? The device has to be very fast. It should be cooperating. So the moment is so that means any faster device you can directly connect to the address. Sorry, bus, which can operate at the same clock as microcontroller. But suppose device is slow. That means whenever you send an address, it will take a lot of time to adjust the address. What to do there? So there is something called handshaking mode of data transfer. Handshake. So how handshake occurs? That means the device has to give certain other signals like, whenever you address it or request for data transfer, one request by addressing, then this will give you I'm ready signal. This is called ready signal. I'm ready. So then you transfer data. So this is a slower thing. So if the device is very slow, then a microcontroller has to just dump it there and forget about it. So that means microcontroller should put a port. So in the port, it will dump the data and forget it, do something else. So this data will be available for more till you do not write again in the port. So it is like, bus station, train station, airport, where the train waits for you, the flight waits for you. It is not that the bus is going, you just on the way you jump into the bus. So that is possible if you are fast enough, but that is not possible when there is a slower device. So this is the difference between bus and port. So as you can see here, everything is connected to the bus. So all these things are very faster. So what happens? This programmable interrupt controller is sitting on the bus. It is sending an interrupt to the CPU after accepting interrupt from IO devices. There are many IO devices which are connected, and there is one interrupt. So there are multiple interrupts are connected to the programmable interrupt controller, which will prioritize it and send it to the CPU. So could you get the idea of programmable interrupt controller? Yes. So now let's go to a typical controller, which will show you. It will give you more idea.
So what is the meaning of prioritizing it?
Suppose two devices are interrupting at the same time. Which one will be processed first? Whose ISS or there are 8 devices, let's say. 8 devices will have 8 interrupt service subroutines. So if there are interrupting together or more than one device is interrupting, the first one should be who is the first one to be processed. So that is called setting the priority levels. Are you getting my point?
Yes, sir.
Okay. So let me show the internal architecture of this. particular, so that you will have a better idea what happens to a interface. You know, there are a lot of interfaces you can see here, which is not exclusively mentioned here. If you look at this architecture, see, each one of them is connected to AVR by way of some interfaces which are there on the board. AD converter, which is connected to the system bus, as you can see the data bus, not directly, there will be internal interfaces, because AD converter is a slower thing. Just like that, SPI, USART, everything are actually chips which are interfaces. So what an interface does, it connects the processor to the external world. Okay, so that things are easier. So if you look at this interrupt controller, so what is the job of interrupt controller? It brings in external interrupts and channels it to the processor which has got just one interrupt. So let me show you the internal architecture of this particular 8259, which is from Intel. Generic architecture I'm showing. This is one. This is a chip called 8259. This is a very famous chip. It is called programmable interrupt controller. There may be other controllers. So what does it do? If you look at this, it takes 8 levels of interrupts, you can see. So this registers all the interrupts. Then it does the priority resolving. Then this way it connects to the processor side. This is the processor side or microcontroller side. So this is connected to the data, and there is some address. There are not many addresses, A0, and there are some comparators like cache 1, cache 2. This is called cascade buffer. We'll talk about it. Then enable cascade. Okay, read write logic, everything. And it has a control logic. Something it is called control register, word register, and there is one command status register. Control word register is writing. Okay, and there is a status register for reading. So by writing a specific bit pattern, there is an 8-bit control word register. By writing a specific bit pattern to this from the processor, you can change many things here. You can change the priority. You can change the label triggering, positive, negative, all these things you can change. And this side, it is connected to the data bus, and it is also connected to, and this is connected to interrupt of the processor, and it receives interrupt acknowledge. Then it will also have, why this data bus is there? Because it is a vector interrupt, so it will also send the ISR address. Okay, the interrupt service subroutine is called ISR address by this through this data bus to the processor. So this is the overall architecture of this. Any questions here?
What does IMR do?
Which one?
Interrupt mask register.
It will, IMR is, sorry, I forgot. So it will mask, that means it will disable certain interrupts. It will put a mask. Suppose you want to disable IR4, so you mask it by that register. Okay. So there are.
How exactly priority resolver works?
So I'll tell you. So the priority resolver is programmed through this control logic. If you put suppose 0, 0, 0, priority IR0 may be highest. If you just change, so there is a sequence of priority. You can see it can be set by some logic. We'll see that now. Okay.
But there might be cases when some external device which has never been seen before for a particular microcontroller can be connected to it. Then what would happen in that case?
Can you again ask the question?
Sir, there might be cases when there is some device that has never been connected before in that microcontroller.
Never connected. You want to connect it, right?
No, I mean never connected. I mean, for instance, the programmer of priority resolver never thought about that, and then someone connects it. Then what would happen with that device? I mean, how the interrupt of that device be prioritized?
You can at best connect 8 devices, right? IR0, IR1, IR2. Whenever there is something wrong, there is a label which will come, which will interrupt it. So all these 8 devices priority is set. So first, which one will come first, which one will come next is already set by this control logic. So whenever you connect any device or any device interrupts, if others are not interrupting, it will definitely take it. But if there is a more than one interrupt coming in, so it will take which one is having higher priority. Is it okay, Ajay?
Yes, sir.
So there are few registers which has to be. So there are few registers which has to be programmed. One of them is called interrupt request register, IRR. Then there is a in-service register, ISR. Okay. So whenever there is interrupts coming through that IR lines, as you see here, so it will be registered in the interrupt request register. It's an 8-bit register. Class. So whenever there is an interrupt request, so it will be registered in the interrupt request register. Whenever the interrupt is being serviced by ISR, it will be registered in the interrupt service register. So these are two registers, IRR and ISR. Please write down. Interrupt request register and interrupt service register. These two. Okay, please write down. So then there is a priority resolver. So this logic block determines the priority bits of sets in the IRR. So when you put the IRR, if you write into the IRR has two places. One 8-bit register for setting the priority, one 8-bit register for registering the interrupt. So it is a 16-bit. When you write, it goes to IRR priority resolver, and when you read, it comes from the IRR register. Okay, the highest priority selected is actually goes to the ISR during the interrupt. So that means the ISR decides which has got high priority resolve. It resolves the priority and goes to that particular ISR. And there is an interrupt mask register, as I said. So it operates. So it disables the interrupt. Okay. So there is a data bus buffer, as you can see, which is basically a tri-state thing. Tri-state, you have to understand. Tri-state means either it is connected two pins. Let's say this is A, B. This is a bus. Either they are connected having a state 0 or 1, or they are disconnected. Sorry. Okay, so tri-state, as I said, if there are 2 points in a digital circuit which are connected, A, B, by a bus or line, it can have a state 1, 0, or it can also have a high impedance state. That means it can be switched off. So whenever this data bus is not connected, it can have a third state called tri-state, so that it will not affect this. So this is called tri-state buffers. You know there are tri-state buffers available in the market. So if you have a third enable, you can enable this so that they'll be connected or they will be connected. So tri-state buffers. And there is a read-write control logic which does what? It actually, there is a command word, as I said, command word register. You initialize this command word for certain operation, certain level of operation. We'll also talk about it. And there is a cascade thing. What is cascade thing? That means you can cascade few controllers, like INT. So I'll show you the diagram that will make things clear to you. You can cascade many controllers here. You can see. That means suppose instead of 8, you want to have 256 or maybe 32 interrupts. You can make it as master interrupt controller, and you can connect other interrupt controllers which will actually interrupt it. That means this is one master interrupt controller, master PIC. The slave PIC can, so this has got 8 interrupts. So this slave PIC can have this one interrupt, and it can also accept 8 interrupts. That means one pin is now multiplied by 8. So anyhow, so I'm going to share the data sheet of 8259. You guys have to just have a look into it, because all your examinations will be open book. So therefore, so this data sheet I am dumping onto you. You guys have a look on this. You open it, then we can read it together. Please have a look of this so that I'll ask some questions, so that interactively you learn many things. It's a very standard chip. You can see this 82599. All of you, please open this. All of you, please open this data sheet. Please download and open. Please download and open. After 5 minutes, I am getting back to you. Okay, so now let us see what is. So I'll be calling one of you. You please open that. From that, go to that page and explain. That's what you have to do. So first, let me start with Doraiswamy. Doraiswamy Bansi, are you there, Mr. Bansi?
Yes, sir.
Please open that 8259 PDF.
Yes, sir. Yes, sir, I'm open.
Okay. So if you are open, so go to this page number 9. So talk about this
Yes, sir.
initialization command words, ICWS. Okay. So ICW1, for example.
Yes, sir.
So what happens? Whenever the command is issued, A0 is equal to 0,
Initializing the
A4
command.
is equal to 1. So what is A0 here? A0 corresponds to what? A0 corresponds to the A0 bit of that controller 8259. A0 is the input.
Input, yes, sir.
Look at this. The HSL circuit is reset, which means that following initialization interrupt request, input must make a low to high times to generate an interrupt. The interrupt mask register is cleared. IR7. So these are called initialization command words. So 8259, if you look at here,
Yes, sir.
initialization command words before normal operation can begin, each 8259 in the system must brought to the starting point by a sequence of 2 to 4 byte timed by WR bar process. What is WR bar?
What is it?
WR bar is the right bar. You are not seeing. You go to page number 8, page number 6. Page number 6. Please go to page number 6. Are you in page number 6?
Yes, sir.
Explain this block diagram. All of you, please open page number 6.
Read right.
So this is right bar means you make it bar. Why it is bar? Because it is enabled when it is low. So this is an
No,
input.
okay. Yes, sir.
This is an input to this. So you have to do that. You know those sequence of operations. I know. Okay, you can stop. Let me go to Nitin Kapadis. Nitin Kapadis.
Yes, sir. Yes, sir.
Okay. So Nitin. So
1 second, sir. There is slight disturbance.
Okay.
Hello. Yes, sir.
Yes. So what is this SP bar or EN bar pin? SP bar / EN bar. If you go to page number 1, look at 16 pin, number 16.
Yes, sir. Opening 1 second.
What does it do?
Pin number 16. So that's like slave pin enable buffer pin, right? It's written
What
new.
does it do? What does it do? Go to the next page and read out. Nobody is asking you to do it.
All right. So basically, this is a dual function pin, and when the buffered mode is enabled, it can be used as an output pin to control the buffer transceiver.
So what is SP and what does it SP? What SP is done?
Okay, so basically when it is not used in buffer mode, the SP is set to 1, that the SP slave program pin. Whereas
what do you mean by why it is required slave program? So what do you mean by slave? So use 8259. Suppose you want to increase the number of interrupts beyond 8, let's say 16. So what to do? Think about it. I'll get back to you.
Okay.
Okay, so let me ask somebody else. Satyuka, Udumula Satyuka, are you there?
Yes, sir.
Okay. So can you tell me why you need slave mode?
Sir?
Slave mode. Slave. What is this master slave thing?
I couldn't hear. Hello?
What is the master slave thing? Master slave. Slave. Master slave. Are you able to get? Can you get me?
Yeah, sir.
Why do you need master slave? Are you getting it? There is picture is there in front of you. The picture is there. You see?
Yes, sir. To control.
No, you are not. Neither you are asking questions nor you are attentive. So problem is. Okay, so Rishita, please tell me.
So, like it will increase if we need 32 and
right. If you need more number of interrupts,
the slaves can be cascaded and we can make into a
right.
master.
So we can same interrupt. One interrupt of one master can be connected to a slave of same controller. Okay.
Yes.
Right. So
yes.
that is required. Okay, so Shreyans Vyas. Shreyans Vyas, are you there? Hello. Is left. Always there. Acha. Vikrant Saraf. Saraf per.
Hello, sir. Yes, sir.
So can you come to page number 2?
Yes, sir.
Can you explain this IR0 to IR7? What are they and what is the sequence of operation and this INT and INTA? These 3 pins you explain what happens when it is required.
So IR0 to IR7 are from pin number 18 to 25, and these are the interrupt requests. And basically, these are asynchronous inputs, and interrupt request is executed when
They are
when we
coming
raise.
from external devices, right? So interrupt request is what? Is it a signal or something? What is interrupt request?
So it is executed by raising the IR input low to high.
Okay. So is it
And,
edge triggered or label triggered?
So it is S triggered. And we hold it higher until it is S triggered.
IR0 to IR7, let's say IR3 is raising it label from 0 to 1. Then what happens?
So it will be
next is what?
Sorry, sir.
Next, what happens? It has to eventually interrupt the processor. Which one is processor interrupt here? What is this INT?
So it is interrupt. It is pin number 17.
So what is this? What is the difference between INT and IR0, IR7? What is that?
So the interrupt pin goes high when a valid interrupt request is asserted. And
it's related to IR0 to IR7. That is my question. You're not attentive, so you should have asked questions. Okay.
Yes, sir. Actually, in INT, this it is connected to CPU's internal pin, interrupt
Okay,
pin.
okay, that's right. So then what happens to INT? IR0 to IR7, suppose there is an interrupt. Then what happens? Okay, Shivam Lahoti. Shivam Lahoti. Shivam Lahoti, are you there? Naam likho. Shivam Lahoti. I told you that you guys, if you don't want to attend the class, you leave. Don't worry. I'm not taking your attendance. Okay. If you're there, Shivam Lahoti is not there. Okay. So Shubham Kumar, you tell once again.
Yes, sir. So the same thing, what happens after?
No, suppose the IR0, IR7, they are interrupts issued by the device.
Yes.
Then what? How INT works?
So like when these interrupts are received by this device, then through the priority resolver, that specific interrupt,
Right.
which is
Also, not only priority resolver, there is also mask register. If it is not masked, if it is not
yes,
disabled,
yes,
then only
it is
will
not
go.
disabled.
So it will go to interrupt. Okay. After interrupt, then what?
So then CPU sends interrupt acknowledgement to it, to this chip 8259, and then it will send the address
So
location.
where the address will go through what? How the address will go to the CPU? Which bus is there?
Address bus.
No, data bus. How can it? D0 to D7? It will go as a data to the CPU. It will go as a data to the CPU by 2 bytes of information, sometimes more than 1 byte. So it will go to the. Okay. Okay, thank you very much. So let me come to Hemasri. Hemasri, are you there? Hemasri.
Yes, sir.
Okay. So is there anything to be written in this device? You want to write something to this device? So what are the things you want to write to the device from the processor?
Like whatever the changes we think.
No, you want to write something to the processor to change certain things. So what is that register? What are the registers which are written from the processor? The processor writes into that. So what are the registers? Can you tell one by one? You go to page number 9.
Okay, sir.
Right, programming these 8259. So
Yes,
there are initialization command words and operation command words. Okay.
Yes, yes, sir.
So you have to do that to program the whole device. All right. So
Okay.
you can go to the next page 10. You can see what happens. This initialization command 1 and initial command 2. Then the sequence of initialization is given in figure 6. All right. So I don't want to take more time. Just I wanted to tell you that you have to read. You have to refer to this particular manual. You don't have to remember anything, but you should know where is what. Right. Just like that, you have got a very big data sheet, that is your Atmega 328. From this big data sheet, there are smaller data sheets which you have to follow, because I'm going to give you some problems which need real open book. So I'm going to share some of the questions which you like. Let me share some of the questions. Okay, please see. So this is long back, 2011. So at that time I was teaching 8051. So I'm showing you, don't worry, just 1 minute. There are 2 questions you can see. Can you see this? Read this question. This is one question. Open book. Okay. You just replace this by something like AVR. 80. At that time I was doing 8051. So I will be teaching. So this is one. This is another question. There are two questions. You can read these questions. So expect such kind of design questions.
Sir, where are the questions, sir?
Huh?
It is not visible, sir. Questions are not visible.
visible?
No, sir.
ठीक है, मैं आपको इसको भेज देता हूँ तो clear कर कि मैं उसको पूरा सारे स्क्रीन रिकॉर्ड करूंगा तो अच्छा आएगा. अभी दिख रहा है?
Yes, sir.
ये एक क्वेश्चन है और ये दो क्वेश्चन है. 2 घंटा में ये दोनों करना है. I am reading these questions. So first one is memory. Okay, multi-access memory. Okay, design a shared memory system. Single 32-bit SRAM chip. The RAM chip is given. This chip I will talk about sometimes. So that manual you have to download. Toshiba का जो है. So by 4 8 mega controllers, not 8051. You can say 8 mega. Replaced by 8 mega. The shared memory chip can operate in several modes such as burst mode, single write, read write. So they are byte write enables and all over BWE enables to write 8 bits information. There are global write enables such as GW. So this has many pins. The 64 kilo into 32-bit trace tab. Draw the block diagrams, make a table that clearly states the address routes, data routes and routes for the control signals for each microcontroller to the bus control unit. So bus controller is the main controller which is also 8 mega or 8051. Then write the step-by-step operation when second 8051 from left needs to read a data from given memory location 3800 to a register. Complement the bits and store them in the same location. Write programs for second MCU and the bus controller MCU to achieve this. Find the maximum minimum possible data transfer rates possible for single CPU to the memory. So ये तुम्हारा देखो ये है. Just suppose तुमको इसको छोड़ के बोलना मैं बोलूँगा कि ठीक है. Let's say hypothetical question is this. Pooja, you can put that question as some assignment. Can you suppose 8259 controller is not available? You want to make one Atmega 328 operate like 8259. And it will be connected to another Atmega 328. Are you getting my question? This can be a question. ये दूसरा क्वेश्चन है. इसमें क्या है? स्विच, डेटा स्विच का प्रॉब्लम है. So there are a variable filter with 8 given sets of coefficients is to be implemented on a 8 mega system. Maybe design the complete scheme that the variable filter coefficients are to be stored in the form of tables. These are the tables EEPROM ka. The first location of each table specifies the order of the numerator and the second location specifies the order of the denominator. Assume the orders both denominator as well as numerator of each not to exceed 3. The values are stored as denominator followed by numerator coefficients. External control is required to choose the specific filter. There are 2 DACs which are specified. Draw the chip level diagram showing the various connections in a table. Specify the pin numbers as well as the names of the pins of each chip. Write the program to acquire the data from ADC, filter it depending on the switch selection and send it to DAC. Use internet-driven data transfer, the timing for ADC clock as well as SOC. Start of conversion to the ADC will be generated from the internal timers of the APR. Find the maximum achieved sampling frequency. ये दूसरा प्रॉब्लम. 1-1 घंटा के लिए है. इसको तुमको कंप्लीट करना है. So I am sending you this question. This is one type of question I am sending you. ठीक है, I have sent it. ये तुम्हारा एंड टर्म का एग्जाम है, देखो एंड टर्म का थोड़ा उस समय मैं अकेला नहीं पढ़ा, सो देयर आर सम क्वेश्चंस एंड टर्म एग्जाम का है, so depends upon this one. This is end term exam 2013. So let's read. So question 1 is compulsory. Okay, and you have to answer question 1 definitely, and question 2 or question 3. So let there be a processor with partially multiplexed address bus, 20 bits with data bus for 8 bits. You can assume the lower byte of address is multiplexed with data bus. Assume read and write as one processor control lines per memory location. Design an interface to realize 1 megabytes of memory with 8 RAMs and 8 EEPROMs as shown below. Clearly bring out the address map and the other circuitry that makes the data address. If the processor runs with a clock speed of 50 MHz, compute the best and worst case memory read times. This is question number 1, 12 marks. Then B, derive the signal to noise ratio for a 2-bit 2-stage delta sigma ID converter, which will be covered. Then C, it is required to design a vector interrupt system for Atmega 162. Look at this. This one is you will get as this. Puja, this one you give change to Atmega 328 and give us their assignment. I have typed here. Okay. So, Puja, are you listening?
Yes,
Puja?
sir. Yes, sir. Yes,
You
sir.
make this an assignment and give it. This 328. You just replace this 162 with 228.
Okay, sir.
It is required to design a vector interrupt system for Atmega 328 system by an external device. Assume the external device receives 4 interrupts at a time and generate a single interrupt or external interrupt 0 apartment. Design a plan so that Atmega this can receive interrupts. So then there is a let a 32-bit register used to print floating point numbers, E bits, design, assign for exponent M bits. Determine the approximate dynamic range of this floating point representation for the following pair of bit assignments. Determine the dynamic range of a 32-bit fixed point represented by single. So this is number representation. Then there is a fifth one is considered 4-segment normalized floating point adder with a 10 nanosecond delay for each, which acquires the pipeline clock period. Name the appropriate function to be performed by the system. So ये अभी पढ़ाया नहीं, पढ़ाने से करेंगे. This is one. This is on the filter. If there is a FIR filter which is given, there are 2 sets of zeros which are clustered in 2 regions. They are very close to each other. So you have to do a fixed point implementation of this. Otherwise, there will be overflow. So I will talk about teaching the fixed point implementation very soon. Discuss on accuracy versus computational time. Guide the modular algorithms for the form of pseudo codes. Bring out the architecture to implement FPGA, etc. Then question 3. Precision control of a robotic manipulator is to be realized using micro-stepping of a stepper motor. Design a micro-stepping scheme using Atmega, using a feedback from optical encoder, blah, blah, blah. So you can, so these are all some of the questions, you know. These are all design questions. So here, be prepared to face such kind of questions.
Sir, in question 1C, what do you have to write?
No, you have to write, see, there is a Atmega has one external input or 2 external inputs, interrupts. So you have to use one external input interrupt and I receive many interrupts, 4 interrupts at a time. In Atmega 328 you have two external interrupts which will read now. So this assignment you have to use these two interrupts to receive more than 4 interrupts. If 4 interrupts occur at a time, you have to design a scheme to accept it. How do you do that? Are you getting my point? In Atmega 328, you can at best receive 2 external interrupts. But suppose there are 4 external interrupts, how will you receive them? Will you be able to receive them by some external circuit?
We are allowed to use like external circuitry for this.
Yes, you are allowed to use. You can use logic gates, you can use flip-flops, whatever. All right, so I will stop here.
Also, sir, like for this assignment, how much time will you have?
This assignment you have 2 weeks.
Okay.
2 weeks time with the interrupt is done. Now, first you have to submit the coding assignment, which I will prepare today. Maybe tomorrow I will upload. That is first, then other assignments. Okay, so let me stop. Any other questions if you have?
Sir, in 8259, why there are two-way connection in priority resolver and ISR, but there is one-way connection between priority resolver and IRR?
Which one is 8259?
Yes, sir.
Yes. What is your question? What did you say?
Why there are two-way connection between ISR and priority resolver, but there is only one-way connection between IRR and priority resolver?
Okay, so ISR, you know, this interrupt mask register and ISR, right? So this is prior, okay. So ISR and priority resolver are connected two ways. So if you, so priority resolver has 2 things. One is, so, okay, just give me a second. So go to ISR, this interrupt service register. So this registers you have to understand, then you will be clear. The ISR described. ISR has to be described. Okay, the ISR, the interrupt at the IR input lines are handled by 2 registers in cascade. The interrupt service request register, interrupt service. The interrupt IR is used to store all interrupt labels which are requested service, and ISR is used to store all interrupt labels. The logic block determines the priority of these bit sets in IRR. The highest priority is this. Okay, so whenever the interrupt occurs, the ISR gives the request. Okay. So, okay, so the events, you go to page number 7. Okay, the events which occurs in the sequence you can read. There is an interrupt request in the IR07, then it is corresponding to IRR. So it is registered in IRR. Then 8259 initiates an interrupt acknowledge cycle. Upon getting interrupt acknowledge, the highest priority ISR bit is set. So ISR bit is the highest priority and the corresponding IRR bit is set. Okay, so therefore ISR has to set the IRR bit also. They are both set. So then call instruction is 2 more interrupt acknowledge pulses to send 825 CPU. Pulses allow it to release its programmed subroutine address. The lower 8-bit address is released and the higher 8-bit address is released. So the complete 3 byte call instruction released by 825, the AII made is ISR bit is reset at the end of third INTA pulse. Otherwise, ISR bit is remaining set. Okay. So this priority resolver, why it is getting, once the ISR service is done, the priority resolver has to move to the next priority. As long as ISR is not, so therefore there has to be input from ISR to priority resolver. Because when the once according to the top priority, that ISR is being set, so that ISR is serviced, then it comes to the next. So the how will you know ISR is complete or not? The processor will update this ISR in service register. So when it is updated, the priority resolver will go to the next priority. That is the way. So when you design for this 4 interrupt, you can understand what is the, you will do manually by using counters and flip-flops. All right, so any other question? अजय मिश्र क्लैरिटी हुआ तो ISR कंप्लीट करने से प्रायोरिटी बिट फिर नेक्स्ट जाएगा.
So IRR is just like buffer here.
ISR.
No, IRR.
IRR is IRR keeps hold of which because the interrupt might vanish. IR0 to IR7 like a buffer.
Yeah,
they once interrupt they may vanish. It will be registered here and it will be made available for this. Yes. Any other questions? Okay. So I shall be sending the coding questions by tomorrow. So be prepared for that. You have to just submit the screenshot and the code. But there will be demo for this. Each one of you have to give the demo. So that is very important. So therefore you have to do by yourself. This has got some marks also from the impressor. Okay. Like mid-sem kind of thing. So be careful. Bye-bye.